Hello everyone. Today we are going to understand generics in Java. So this was introduced in Java 1.5 and the main motivation behind generics was to identify the compile time error, improve the type safety, reusability and better maintainability. So we'll understand this with examples. What are the benefits of generics in Java and how can you use it? So let's understand this with an example. This is my list and this is the interface and this is the concrete implementation array list. I add a string here. So this is ideally a string list. Now when I try to retract the value list.get0, it would need a casting because I have not provided any type here. So list.get0, then I do the type casting here and then I take it in string str. Now if you compare it to generics list of string, here we are mentioning the list is of type string. And when we try to retrieve it, no casting is required. So this is the type safety part. And suppose say this is a string, and if I try to cast it into integer, so this would become a runtime error, not a compile time error. So this is what we are saying when we say early error detection. We'll see this the code example. Let's try this out. We take that same example. I have list of list is equal to new array list. Here I don't define the type. So I add the string here. Hello. Now I'll take this string. If I do get0, see that it gives me this error. I need to cast this because compiler is not aware whether it's a string or with what type because you have not mentioned it here. If we run it, it will run fine. Now let's take the other example. I add list one here. Now instead of this, I do this. Okay. So now what I'm doing in list one, I'm taking this value. Basically, I created this list. Then I'm adding hello, and I'm fetching this value from index 0. But what I'm doing is I am storing it into an integer variable. This, as you can see, there is no compile time error. It compiles fine. So here you can directly see two benefits with generics. First of all is the compile time error that we'll see with the example, and the second one is you can avoid casting. Now let's see what happens here. See, as you can see, you get the runtimer. So this was a string, and the runtime it tried to convert it into integer, and it failed. Now we will see in generics how it becomes type safe. Type safe using generics. You take this whole code, make it string here, list 2, add value list 2. Now if you look here, first of all I don't need to do any casting. As you can see, it is giving me error. Why it is giving me error? Because compiler knows that this is a string list, and what I'm doing is I'm storing it into an integer. So as you can see directly the benefit, compile time error, that is early error detection. So you get a clean code basically. Now I'll just amend this one. I'll take it as a string. So I do here. As you can see, it works fine now. If I run the code, this will fail actually. Just 1 second. Note it out. As you can see, it works fine. No issues here with the generics. So that's the advantage of generics. Let's create the object of data store. Here, here I pass because it's a string, right? Hello. Okay, void. Here is the key in void access. If I try to create another object, it's not make it string. If you can see here, I cannot pass any type, any other type other than integer here. So suppose I want to pass 1.5, I cannot do that. So this is the problem that we face with this kind of implementation. So basically, suppose I want any other combination of key and value, then I would have to create different types of data store classes. So this is kind of repeating the code because your data type is changing of your instance variable. So how generic will help us? Let's see that. So for now, let's make it key comma value. So this is how you define the generic types. You can name anything here. These are general T, V, U, etc. These are the conventions. For key and value, I am using K and V. So this is my K and this is my V. This is my K and this is my V. So it compiled fine. So this is how you define your key and value. Okay. So basically any type. There are two different types. I can set two different types. I can have multiple as well. If I want W, whatever you want. You can number of types is dependent on it. For now I just need two. So I have defined two values here. Now let's see how we can use this in the data store example. In the first case, I want integer comma string. If I do this, it works fine. And if I want, I will just use float comma integer. Sorry, integer comma float. Let's make it integer comma float. Integer comma float to 0.5. It works fine. Then suppose I want any other type. Let's make it string comma. Let's make it string comma string. We'll just make it key 1 comma value 1. See how the same code is now being reused because of generics. I just pass whatever type I want for my key and value, and that type is being taken here. So data store, the key started with integer and string. It worked fine. Then integer and float, it worked fine. Then string and string, it worked fine. So this is how you can define at the class level. You create one static method here. It returns nothing for now. Just prints. And for now, I'm passing integer. Like take integer. And what I do is shout from value is. This is what I'm doing here. If I call it here, so this is my print class, print method. If I pass one, it works fine. So suppose if I want to pass hello world, doesn't work. So if I want to pass floating point number, it doesn't work. Suppose I want to pass long, it doesn't work. Suppose I want to pass value, it doesn't work. So it supports only integer. So what we can do here is we'll use the generics. How we'll use generics here? I'll make it t now, but it doesn't understand what is this t. So to make it understand that it's a generic type, so before your return type and between your return type and your access modifiers, you can use this diamond operator, what we had seen in data store as well. This is called as a diamond operator. So currently I have only one type, that is why you see that one type. You can name it anything you like, you can make t, p, q, whatever, but the good convention is t, v and all those things. And as you can see, as soon as I made it generic, same print is working for all of this. And if I run it, here you can see it is printing all the values. So this is the advantage of, and say suppose I pass another string item 2, just to keep it simple. So not same type, let me keep it of different type. We'll make it u. So again, as you can see, it doesn't know what is u. To make it know, you add u here, simple. And what I will do is, so something like this, just for the example sake. Okay. Here I am passing two values. Let me pass, this is integer. This is string. For float, what I will do is I will pass some other type. Let me pass 100, integer type. Here I will pass double. In case of double, I will pass long. And if I run it, as you can see, the first two were integer and string, then string and string. Third one is float and integer. Fourth one is long and double. Fifth one is double and long. So this is how you can play with any type. That's the advantage of generics. So this is how you use in the method. You can use in any method. And for class or interface, you have to define it like this. Right after the name of the class, in the diamond operators, you put the name of all the types. Basically, the letters that you are going to denote. K, V, T, U, etc. Let's take one more example of string array. A comma B comma. I create another method which takes any type for now. And because I know that this would be an array, this is how you define. This is of type T, and this is an array. in this side. I'll call this method not print, maybe I'll call this print array, string array. Let's see the output. As you can see, I can see ABC. It works fine. Now let me try with an integer array. Comma 2, comma 3, comma 4. This is integer array. It works fine. No compilation error, as you can see here. Now instead of this integer, if I make this as primitive type, see it starts giving me compilation error. So why this happens in the case of generics? Because you cannot pass primitive types. Just keep this in mind. We have to always pass integer or the wrapper classes. Okay, that's one of the important points, because internally when the code is compiled and kept, what Java does is all this K, V, everything is replaced something like this. So this happens during after the compilation. So just keep this in mind. This is an important point to remember. So that was the introduction to generics, how generics is beneficial. Let's go through that again. So you can see that it makes the code type safe, because you are not doing any type casting, which will be detected at the runtime. Then because of this, you will get the compile time errors, not the runtime errors. Then you can see that same code, it could be a class, it could be a method, you can reuse it for many different types. And then the code also becomes very simple, easy to read, and even the maintainability also becomes easier. So that's all about the introduction to generics. We will see later on the other details of generics. Thank you so much.